Hello everyone, welcome to Payment Tech Media. In this video series, we will talk about IPv4 subnetting. So stay tuned, let's jump into my computer and take a look. So in previous videos, we talked about IP address, IPv4, we talked about different classes and their default subnet mask. Now let's talk about classless subnet mask. So what is this classless subnet mask? Or what is this IPv4 subnetting? What is the purpose of subnetting? As we previously talked about, that pretty much anytime when we want to manage and be able to better organize our devices on the network, we probably want to break a large network into the smaller network to better manage the devices on the network. Or sometimes we don't want to waste too many IP addresses. So let's say a company with only 20 employees, or let's say 20 computers, devices on the network, so doesn't need 254 IP addresses. So breaking large network into the smaller network, not to waste too many IP addresses. Or another reason could be because of security reasons. So let's say having specific subnet designed for human resource department, specific subnet designed for marketing department, and another subnet designed for finance department, sales department, and so on. So basically, be able to break a large network into the smaller network. So that's subnetting. So previously, for quick recap, as we talked about in IPv4, we have 5 different classes. Class A, B, C, D, and E, which we talked about mainly. Class D is for multicast purposes, and Class E is for scientific and research purposes. And mainly, we will have subnet mask for Class A, B, and C. So the default subnet mask for Class A, as you guys already know, is 255.0.0.0. And default subnet mask for Class B is 255.255.0.0. And the default subnet mask for Class C is 255.255.255.0. Which again, these subnet masks, these are decimal notation format. And here in IPv4, as you guys already know, we have 32 bits. And this is the binary format. And you can see all the 32 bits. So this is the first 8 bits, the second 8 bits, the third, and the fourth. This is also known as the first octet, second octet, the third octet, and the fourth octet. So here, this is the decimal representation of this octet. So this is the first octet, the second octet, the third, and the fourth. In the previous videos, we talked about how we can convert binary to decimal or decimal to binary. Please make sure to watch those videos. So here, this 255, it pretty much means here we had 8 ones. And anytime in any octet, all the bits turned on, we have to add all these decimal values to the top. So 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 and plus 1, which gives us 255. And previously we talked about that 1 means on and 0 means off. So 1 is network bits and zeros are host bits. For example, in Class A default subnet mask, we have 8 bits for network bits and we have 24 bits for host bits. So these are the default subnet mask. For Class A is the first octet for the network. Class B, the first 2 octets for the network, and Class C, the first 3 octets for the network. Therefore, it gives us only the last octet for the host. So we will have 8 zeros in Class C, the last octet, 8 bits for host, and 24 bits for network. In Class B, 16 bits for network and 16 bits for the host. Again, these are the octets, decimal representation of these binary numbers. So if this is 255, 8 bits here, the second octet 255, 8 bits here, the third octet 0, so 8 bits 0 here, and the last octet 0, 8-bit 0 here. But of course, this one is for class A. For class B, it would be, let's erase all this, and let's add all this as well. So this is an example of class B default subnet mask, 255.255.0.0. And for class C, let's erase all this and add. So we have 24 bits for network and 8 bits for host. That's a total of 32 bits. Again, in IP version 4, we have 32 bits. So previously we talked about the number of hosts. So number of hosts is 2 to the power of host bits minus 2. Which, when we talk about, let's say, class C, how many host bits do we have? Only the last octet it's for the host. So in the last octet, 8 bits of zeros. Here we can see 8 bits of zeros. This is for class C, default subnet mask. So 2 to the power of 8 minus 2. 2 to the power of 8 is 256 minus 2, which is 254. Therefore, default subnet mask class C, every network we will have 254 available IP addresses. That's why we do the minus 2, because one IP address for network address and one IP address for the broadcast address, and all the available IP addresses in between, that's the available usable IP addresses that we can use. Again, in previous videos we talked about a lot more in detail when we went over the default subnet mask for each class. So always this address will be the network address, and this address will be the broadcast address, and all the available IP addresses in between, these are the usable IP addresses we can assign. So when we do the minus 2, we are basically reserving one IP address for network and one IP address for broadcast address, and the result is pretty much all the available IP addresses that we can use and assign to the computers on the network, to the interfaces, devices on the network, and so on. So this class C default subnet mask gives us 254 available IP addresses, right? It's pretty much like a big box with 254 available IP addresses. Now let's say we want to break this big box into the smaller boxes. So let's say into the 4 smaller boxes. That's an example of subnetting, breaking a large network into the smaller network. And how can we do that? By borrowing from the host bits. Which, speaking about borrowing from host bits, it's pretty much when we have our network bits, and this is the host bits, the zeros, it's pretty much taking away from the host bits and borrowing into the network bits. So all these ones, these are the network bits, network bits, network bits. Here we borrowed from the host bits. This will be our subnet bits. And the zeros, it's our host bits. So in this case, we have 24 network bits, and that's the default subnet mask for class C. We borrowed 3 bits to be part of the network bits. We turned on these 3 bits from the host bits, and it goes from left to right. So here, 1, 2, 3. 3 bits we borrowed. This is just one example. And here we have 5 zeros, 5 host bits. So now our cut line, it's not here anymore. Originally it was here, but now it is here. So what would be the CIDR notation? We have to count the number of ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and up to here, 24, 25, 26, 27. So that will be our CIDR notation. /27. Classless interdomain routing, known as our CIDR notation. So if we want to convert all this binary into decimal to write down our subnet mask, would be our new subnet mask is 255.255.255. How many bits here? Borrowed 3. So basically this is an example of converting binary to decimal. Again, previously we talked about how we can convert binary to decimal. Make sure you watch those videos. So here we have only these 3 bits turned on, so we have to add the decimal values for these 3 bits. 128 plus 64, that's 192, plus 32, that's 224. So this is our new subnet mask. Is this default subnet mask? No, because default subnet mask for class C is 255.255.255.0. But this one is 255.255.255.224. What does it mean? Means that we did borrow 3 bits on the last octet, because here we can see the 224. So remember, every octet that we have all the 8 bits turned on, that's 255. This is the first octet, all the bits turned on. Here the first octet, 255. The second octet, all the bits turned on, second octet, 255. And so on. The third octet, 255. And here we can see on the last octet we have only 3 bits turned on, so that gives us 224. Now if we apply the same formula that we talked about, the number of hosts, 2 to the power of host bits minus 2, right? So originally we had, for class C default subnet mask, we had the last octet all zeros, right? So we had 8 bits of zeros, 2 to the power of 8 minus 2, and it gave us 256 minus 2, 254. But what about now? Let's see. By borrowing these 3 bits, therefore we will have only 1, 2, 3, 4, 5 bits left for the host bits. So let's erase all this. So we have 2 to the power of host bits. How many host bits do we have now? Zeros represent the host bits, ones represent the network bits, right? So the zeros representing the host bits, we have only 1, 2, 3, 4, 5. 2 to the power of 5 minus 2. Again, minus 2 because of the network address and the broadcast address. So we do the minus 2 to get a usable IP addresses, number of hosts that we can assign to the computers. So 2 to the power of 5, that's 32, minus 2, that's 30. So we will have 30 available IP addresses per subnet. So this section, again, you guys already know the default subnet mask for class A, for class B, and for class C, right? I'm gonna go ahead and erase all this to make some space. Okay, so this is just one example of subnetting. We did break large network, let's say default subnet mask class C, into the smaller network, and we borrowed 3 bits just as an example. And then we did find out our new subnet mask and then the CIDR notation. Just remember, this CIDR notation and the subnet mask is pretty much the same. This is the full version writing down the subnet mask, and this is just a short version of the subnet mask writing the CIDR notation. The /27 means 27 being turned on. The number of ones turned on, number of zeros turned off. Ones, network bits, zeros, host bits. And applying the same formula, now we did find out that we will have 30 available computers per subnet. You see, now we are saying per subnet. So originally, the default subnet mask for class C, we will have 254 available IP addresses per class C network. But now, with this CIDR notation, this subnet mask, we will have 30 available IP addresses per subnet. We do have also a formula to find out how many subnets we will have. Let me erase this. So to find the number of subnets, 2 to the power of subnet bits. So in this case, how many subnet bits we have? 1, 2, 3. So we borrowed 3 bits from the host, all the host bits, right? So these are our subnet bits. So it is 2 to the power of 3, which is 8. So it gives us 8 subnets. And each subnet, we will have 30 available IP addresses per subnet. So in other words, let's erase this. Originally, we had a default subnet mask class C, 255.255.255.0, that gave us 254 available IP addresses per network, right? If we had this big box with 254. And but right now, using this CIDR notation, 27, now this is subnetting. So breaking down this big box into the 8 smaller boxes. So now after subnetting our big box, it's pretty much divided into 8 smaller boxes. So let's draw 8, 1, 2, 3, 4, 5, 6, 7, 8. So here 8 smaller boxes inside this one big box. So originally default subnet mask class C, we had one network with 254 available IP addresses per network, right? So after subnetting, in this example, we just borrowed 3 more bits from the host bits, right? So that's a total of 27 now, 27 bits for the network, and only 5 bits for the host, which we talked about. The number of hosts, 2 to the power of host bits minus 2, because of network address and a broadcast address we cannot assign to the computers on the network, so we have to do minus 2, 1 for network address and 1 for broadcast address. So that gives us the number of hosts. 2 to the power of host bits, here we have 1, 2, 3, 4, 5. So 2 to the power of 5 minus 2, which is 2, 4, 8, 16, 32. 32 minus 2, so that's 30. So basically, in other words, we have 30 available IP addresses per subnet. So let's write 30 here. So this is an example of subnetting class C network. Originally one big box with 254 available IP addresses, broken down into the 8 smaller boxes. Now each we have 30 available IP addresses per subnet. And this is just because of this subnet mask. Now it depends if we had different subnet mask, different CIDR notation, different cut line. So it would give us different number of subnet bits and different number of host bits. Based on that, we could find out how many subnets we have and how many available IP addresses we have per subnet. Now let's see this in action. So I'm going to go ahead and erase all this. So let's say they gave us IP address, class C IP address 192.168.1. Let's say 82. And of course the CIDR notation is, this is 8 plus 8, 16 plus 8, 24, 25, 26, 27. So the CIDR notation 27. And we already know this CIDR notation 27 gives us 255.255.255.224. Where this 224 is coming from, here on the last octet we can see 1, 2, 3 bits turned on. So this, here we can see 128 plus 64 plus 32. That gives us 224. Basically once we just need to add, when we convert binary to decimal, we just need to add the decimal values of the bit positions that it's being turned on. In this case, this one turned on, this one turned on, this one turned on. So 128 plus 64 plus 32 gives us 224. And again, why here 3 bits? This is just one example to show you guys subnetting, but we will in the future talk about based on the number of hosts, where we need to draw a cut line, all that. Okay, so having this IP address and the CIDR notation 27, they said this IP address, find out this IP address belongs to what network. So in the previous videos we talked about the ANDing formula, and same applies here. If we convert this IP address into the binary and convert this subnet mask into the binary and applying the ANDing formula, and the result, when we convert the result to decimal, that decimal is our network address. Okay, so we have to start from the 0 network. This is class C, default class C. Subnet mask is 255.255.255.0. So let's write down 192.168.1.0. That's the 0 network. How do we know? Because again, 192, the first octet, falls into class C, and the default subnet mask 255.255.255.0 for the default subnet mask class C. Therefore, the last octet is the host bit. So for the host bit, we just put 0. And here we can see this is our network address. Let's open parentheses to see our range. And then here will be our broadcast address, which we talked about previously. The easiest way to find the broadcast address is to find the next network first. And then one IP address less than next network is our broadcast address. So how can we find out the next network? It's basically by the use of network increment or block ID. So the last bit that is turned on, the decimal value of the last bit that is turned on, that's our network increment. In this case, what is the last bit that is turned on? Again, left to right. If we continue all the bits turned on, this is the last bit that is turned on. So what is the decimal value for the last bit that is turned on? 32. This is our network increment. So we are incrementing by 32. On what octet? On the last octet. Because we are working on the last octet. The cut line is on the last octet. So the next subnet, you see, I said the next subnet, not the next network. If we follow by the default subnet mask, that would be the next network. But because we are using subnetted bits, so it's known as next subnet, which is another network basically. So breaking large network into the smaller network or subnetworks. Okay, so the next subnet would be 192.168.1.32. Why 32? Because again, the last bit that is turned on here, this is the cut line, after that is 0, right? So this is the last bit turned on. The decimal value, 32, that's our network increment on the last octet. So on the last octet here, we put 32. And remember, these are the network addresses in this column. And here in this column, our broadcast addresses. Okay, if I want to continue, moving on to the next subnet would be 192.168.1.64. If I want to continue incrementing by 32, keep incrementing by 32 because of the network block ID or network increment ID. Okay, that's fine, that's enough. We should be able to easily write down our broadcast address, which again, the broadcast address is one less than the next network or the next subnetwork. In this case, this is our first and this is our next network. So the broadcast address for the first network would be one less than this, which is 192.168.1.31. If we add one IP address, it would be 32. Okay, so that's our broadcast address here. Now let's go over the ranges. Available IP addresses. So the first available IP address in this network would be 192.168.1.1. That's the first available IP address, and it goes to 192.168.1.30. And here you see this is one subnet, or one, as I mentioned earlier here. So, and each subnet we can have 30 available IP addresses, and here as we can see 1.1 to 1.30, that's 30 available IP addresses. If we count 1.1, 1.2, 1.3, I'm just kidding, but it should be 30 available IP addresses as we can see here. If we want to move on to the next subnet, the broadcast, one less than the next subnet here. So for this subnet, let's say this is subnet 1, subnet 2, subnet 3, and here for subnet 2, we have the broadcast address is one less than the next subnet, which is subnet 3, 1.64. So this one should be 1.63. Again, 192.168.1.63, because the next one is 1.64. And the available IP addresses, the range now goes in between basically 1.32 to 1.63. So that would be 192.168.1.33, and it goes to 192.168.1.62. So these are the available IP addresses in this subnet. So let's say if this is our other subnet, for example, and we have 30 available IP addresses in that subnet as well. Again, here we can see 1.33, 1.34, 1.35 to 1.62. That should be 30 available IP addresses. So again, remember, with the CIDR notation of 27, subnet mask of 255.255.255.224, we can have 8 subnets. We can have 30 available IP addresses per subnet. So far, you guys saw this 30 available IP addresses per subnet. But let's go ahead and take a look. Where is this 8 subnets? Okay, do you remember the last bit we talked about? That's our network increment. We have to keep incrementing by 32. So if we keep incrementing by 32, you will see we will have up to 8 available subnets. After that, it goes to the next network, which I'll show you guys right now. So let's continue incrementing by 32. So 64 plus 32, that's 96. 96 plus 32, that's 128. 128 plus 32, that's 160. 160 plus 32, that's 192. 192 plus 32, that's 224. And 224 plus 32, that's 256. I'm going to write down here dot 256, and I used different color because in IP address, IP version 4, we don't have 256 in an octet, because every octet the range goes from 0 to 255. Why? Because every octet we have 8 bits. That's actually the name coming from octet, octal, octagon, right? So we have 8 bits, number 8. So if all the 8 bits turned off, that's 0. If all the 8 bits turned on, that's 255. So if we continue incrementing by 32, right? So here earlier we talked about our network increments. So after, when we get to 224, 224 plus 32, that's 256. So what happens here, it will be 192.168.1.256, right? And again, we don't have 256, so it will turn to 0 and add to the next octet to the left, which is 192.168.2.0. And here 2, we are on the 1.0 network. So if we go to 2, we will be on different network. Therefore, here we can see the CIDR notation of 27, or the subnet mask of 255.255.255.224 will give us 8 subnets. This is the first subnet, second, third, the fourth, fifth, sixth, seventh, and the 8th subnet. After that, the 9th subnet, that's 256, which we talked about, that's not correct. It will take us to the next network. So when we talk about the subnets in the 1.0 network, it's total of 8 subnets, including the 0 network here. So here we can see, by just borrowing 3 bits here on the default subnet mask for class C, gives us a CIDR notation of 27. The subnet mask of this value, we can have, instead of one big network with 254 available IP addresses, instead of that, we can have 8 different subnetworks, and each subnetworks we can have 30 available IP addresses per subnet. Okay, so this IP address now falls into which subnet? What do you guys think? So let's erase all this. And here we can see 82 on the host bits, right? 82. So 82, and here we can see the increments. So 82 falls into which one? It's not between 96 and 128. It's between 64 and 96, correct? So it is in this subnet. in the 1.64 subnet. And the broadcast for the third subnet is 1 less than the next subnet. 96 is the next subnet, so it is 192.168.1.95. So 1.95 is the broadcast address for this subnet, and this IP address 1.82 falls into the 1.64 network. So the first available IP address in this subnet is 192.168.1.65, and it goes to 192.168.1.1 less than the broadcast 94. If we add one IP address, 95, that's the broadcast. If we add one IP address, 96, that's the next subnet. Why? Because of this subnet mask 255.255.255.224, which it gives us the cut line here, this 224. On the last octet, if we convert 224 to the binary, that's 111000000. So we know between 1s and 0, if we draw a cut line, the last bit that is turned on, 32, our network increment. So in other words, this IP address falls into this subnet. And the network address for this IP address with this subnet mask would be 192.168.1.64. And again, if we convert this to the binary, and apply both of them the ANDing formula, when we get the result, the binary result converting to the decimal, we will get 192.168.1.64. But this is another way to find out the network address for this IP address with this subnet mask. And therefore, let's say if this is the third subnet, and here 1, 2, 3, so this IP address would be on this subnet. So between 1.65 to 1.94, 1.82, it's between in this range. And the broadcast address here, if a router receives a packet with the IP header destination address of 192.168.1.95 with the subnet mask of 255.255.255.224, the router will forward the packet to all these IP addresses here in this range. So this will be the broadcast address for this network address with the subnet mask of this. And again, this IP address falls into this range in this subnet. This was an example of IPv4 Class C subnetting. I hope this video was helpful. If you liked the video, please hit the thumbs up. To see more tech videos like this, please subscribe to our channel. In the next video, we will talk about more examples of Class C, Class B, and Class A subnetting. So thank you so much for watching and have a good day.